Today we'll look at one of the security problems with LLM-based applications and also a way to mitigate the negative impacts of it. So I built this demo grocery app, which is backed by a SQLite database and has an AI chatbot. The bot could assist the customers with their shopping queries. The bot generates answers based on the records in the grocery store's database. As we can see here, it pulled up some records on the price and stock availability of carrots for the query we asked it. Since it is backed by an LLM, we could override the system prompts and make it generate content that is out of the intended context, such as this. Here I am using the ignore all previous instructions trick to make it answer a question that has nothing to do with groceries. This is a benign example, but we can surely imagine what kind of troubles this could lead to in our application in terms of content safety and guidelines. This is essentially a prompt injection. In this video, let's look at a way to mitigate this. The idea is we have an app that accepts inputs from the user, which are prompts for a downstream LLM service. In our case, this is just forwarded to OpenAI API with some modified context retrieved from our database. Then we return the response from the LLM to the user. There's no input validation. And unlike typical apps, the use of natural language as prompts makes it harder to validate the input. One among the many approaches to solve this problem is by placing an LLM to validate the intent of a prompt before proceeding with the application logic. This approach, which is usually referred to as LLM as a judge, is an input validation technique. The forward-facing LLM determines if a prompt is valid or not, based on the criteria we provided. If the prompt passes our set guidelines, we proceed with the application logic and make further LLM calls. If it is not, then we immediately return a message and stop the execution flow. Let's look at the implementation. So I have this method named validateUserPrompt, which takes in the user prompt as an argument and returns a Boolean value. I have set up some intents that are to be blocked, and then I provide this detailed guideline as the system prompt to the validation model. The model I'm using as a validator is GPT 3.5 Turbo, so I had to instruct it specifically to evaluate all criteria because it was missing a few if not specified. My reasoning for going with 3.5 Turbo is mostly for cost optimization. Then I set the guidelines as the system prompt and the incoming prompt to validate as the user prompt in the chat completions API. I also set the temperature to 0 because we don't want any randomness in the evaluation. And the max token is set to 10 because the output will always be a single word. That is, it will be either valid or invalid, because that is what we have instructed it to do in the system prompt. Then I cast the response to uppercase and check if it equals to the word valid. Now let's plug this validator into the API route that interacts with the LLM in our application. So we'll validate the prompt before performing any retrieval or chatbot answer generation. And if the input prompt violates our constraints, we just return a hard-coded denial message. Let's see this in action. Let me try the previous trick of ignore all instructions prompt. This time we can see that the prompt is rejected with a hard-coded message, and the chatbot doesn't generate a response for this. This is because the validator identified this prompt as invalid before passing it down the further chain of execution. Let's make a legitimate query. We can see that this passes through our validator and we get a response from our answering bot. Let's try to go outside of the constraints and ask an unrelated query such as this one related to stock markets. We could see that the validator LLM now rejects these unrelated prompts. Let's try to use a word like cheese, which will qualify as a grocery item, and try to bypass the system prompt. As we can see, our validator caught it and blocked it. This is not a perfect solution, but this is a good starting point and definitely better than nothing.